Hello everyone, welcome to the second lecture for Lesson 1, working with numbers and arithmetic. The objectives for this lecture will be to explain the difference between an integer and a floating point value. In C#, we'll be looking at int types and double types for those two respectively. And we'll talk a little bit about the differences there and when and why you would want to use one over the other. We'll also look at how to declare variables for numeric types. In the previous lecture, we looked at declaring variables for string types, and in this one, we'll look at some additional ones. We'll talk about how to capture input that's numeric from the user. So again, previously, we had captured string data from the user. Today, capturing numeric data. That'll be a little bit different. And finally, working with arithmetic expressions to create new values. So we'll be creating some different expressions. We had seen concatenation expressions in the previous lecture, but in this one, we'll be working with numbers and arithmetic. And then, of course, finally, to display those values. So without spending any more time here, let's get it. All right, so as you can see here, again, I've got Visual Studio set up, open and ready to go. If you don't have Visual Studio opened up, I recommend you do so now. We'll create a new project for this little lecture that we'll do together. And on the right side here, I've got a Word document, again, with a very simple problem statement. We'll use that as the basis for working through the concepts in this lecture. And again, we'll be going through the different problem-solving activities just so we can keep those fresh in our mind and so you get familiar and comfortable applying those in your problem-solving and programming practice as we go through the term. So just reading the problem statement together quickly here, what we're presented with is a task to create a program that will convert a temperature from degrees Celsius to degrees Fahrenheit. It's pretty straightforward conversion calculation, and it's a very simple program. Again, it's not supposed to be complex, but there's enough there for us to explore the things that we need to for the objectives of the lecture. So in addition to being tasked with, hey, create this program to do the conversion, we're also given a basic conversion formula. So the degree C is multiplied by a value, and then we add that result, the product, to 32, and then we get the degrees F. So pretty straightforward there. And we've got some indicators for what may or may not be variables within the program itself. So very similar to what we had done in the previous lecture, what I'm going to do is first determine what my model for the program is going to look like. And then we can look at creating a plan for our model going forward. And again, this is going to be pretty straightforward. We're not going to spend a lot of time here making sure we understand the problem. But again, generally, I would say we're being tasked to do really three things. The first is to capture some input from the user. And then the second is to take that captured input, do some arithmetic to convert to another value. And then the third piece is to simply display the new calculated value, in this case, our degrees in Fahrenheit, back to the user. So again, we could use a flow chart or something. I'll use, basically poor man's process diagram, but it works to get the point across. So we'll have to capture some input, and then we're going to perform a calculation. And then we're going to display the result. And again, we could read that back to ourselves. We could share that with someone else to see if our thinking makes sense. And once we feel pretty good about our handling and understanding of the problem itself, then we can move on to create the specific planning statements that we want to use to implement this. Again, here I'm just going to use a form of pseudocode. You don't have to follow exactly the same pseudocode format that I'm using. If you use parts of it or you switch it up or you use something entirely different, that's totally up to you. Again, what I care the most about is that you're able to create plans that make sense and that are easy to follow. So you should be able to share your plan with someone else and have them understand everything that they need to know in order to implement that in a programming language. So whatever route you choose to create your plans, whether they be pseudocode or flowcharts or what have you, just keep that in mind. The idea would be that if you were to share that plan with another programmer, they would know what to do and be able to take that plan and implement it. So we're going to have to do a couple of things here. If we go back and revisit the problem statement, we can see we're going to need a temperature in degrees Celsius. So that's an important key piece. We're going to need degrees Fahrenheit. And of course, we're going to have to do a conversion. So those are really kind of the key pieces here. It's one sentence, so there isn't a whole bunch there, but those are the key things to pull out. So when we think about that in terms of our planning, we can start to think first, like, what are the ingredients that we're going to need? If this were, likened to a recipe, we have a number of ingredients that we need to capture first and be aware of, and then we go through the steps of how we're going to implement the capturing and the mixing and the displaying of those values, and then we can put it all together. So I'm going to, first of all, to indicate here that we need to declare some variables. So I'm going to declare degrees Celsius, and I'm going to declare that as a numeric type. So right now we have to pause and ask ourselves, all right, it's a number for sure, but what type of number? So we're aware that there are two types of numbers that we can use in programming. And those are integers or whole values and floating point values, or any kind of real number that we can think of. So the question is, do we want to create a program that does a conversion for whole numbers only, or do we want to have decimal precision? And we probably want to be as accurate as possible. So it's likely we want to be able to input more precise values and not limit it to whole values. If we had someone around that originally gave us this problem statement, a client or someone that we were working for, we would want to clarify with them exactly what they expect the input to look like. But for now, we're kind of left to assume. So we'll make the assumption that more precise is better. So I'm going to just go ahead here and say, I'm going to declare degrees Celsius as double. Again, here in the pseudocode, I'm typing double. If you wanted to be more generic and just say that you are creating this as float, that would be fine too. Again, given that float here in my pseudocode plan, all that's indicating is that it should be a floating point value. When we go to implement it in our programming language of choice, we would have to take that as a plan and convert it to the implementation type for C# in this case. So even if my pseudocode, as it does now, says declare degrees Celsius as float, when I go to create that in our code, I'm going to implement that as a double. So I'll leave it here as a float so we can see that. Again, the plan is just that. It's a plan. It doesn't say exactly how you're going to do it in your programming language of choice, but it does tell us what we need to accomplish in our programming language of choice. So in addition to a degrees Celsius as float, we're going to also need a degrees Fahrenheit. And that's also going to be declared as a floating point type. Okay. Now, again, those look like they're the only two variables. We don't know what the input value is going to be. We don't know what the calculated value is going to be. So we need variables to hold those values for us. After we've declared those variables, the next thing we may want to do is then capture input from the user. I'm going to take a sidebar here for a moment. One thing that we're not going to do in this particular program, and I'll introduce it in probably the next lecture series, is just adding a bit more aesthetic for our programs. So for this solution, we're just going to jump straight into prompting the user for input. But it would probably be nice to display some kind of a program title so that when the user runs the program, they know exactly what program it is that they're executing. And so if some of you were thinking that, hey, are we kind of skipping something, or I feel like something is missing, that may be what that feeling is telling you. And I would say you're right. And we'll start to implement that in future solutions. But for right now, we're just going to focus on building our skills up for the basics, which is just focusing on, in this case, getting input, doing the calculations, and displaying the output. The additional aesthetics and niceties for user experience, we'll continue adding those as we go through the course. So for now, after we've declared our variables, we're ready to then prompt for a value from the user. So I'm going to prompt something like enter degrees Celsius. And we're going to input the degrees Celsius variable. And then once we've captured that value, we're ready to do the calculation. Now, I've already got the formula here, but if you were just given this statement at the top, and that's all you had to go by, you may have to do some digging around to find this formula. So there will be cases in this course where you're not given things like this, and you will be expected to use Google or whatever search engine or means are available to you to find these things out. Okay, so in this example, we've been given the formula, but if we weren't, we would have to just go online and find it. And that's all part of the problem solving process. At the planning stage is to, okay, well, we're gonna have to do some calculations. We need to figure this stuff out. Let's do some research and then get all that out of the way now so that when we get to our actual implementation or coding activity, we're ready to go. We don't want to be scrambling around looking for formulas and things when we're ready to code. All of that should already be taken care of. So the calculation is going to be pretty straightforward. I'm going to indicate here that we're going to set degrees Fahrenheit, and we're going to assign that a value which is based on this formula. So it's going to be the degrees Celsius value that we've just input. Again, typing's a bit bad here. So degrees Celsius. Oh my goodness. And that's going to be multiplied by a value of 9 divided by 5. Now they've used parentheses in the formula here to indicate that this is a grouped expression. But of course, multiplication and division have a higher precedence than addition. So this would happen before the addition of the 32 anyways. But there's no harm in being explicit about what it is we're trying to do. So we can also include the parentheses here. Notice I'm using the asterisk operator here for multiplication. And then finally, we can add the value of 32. So we can do a quick eye check that this formula is in line with the formula we have here. Fantastic. It looks pretty good. Let's step up to the next and final stage, which is to just simply then display something like, we can be explicit. So let's do something like degrees in Celsius. We'll display that back. So degrees Celsius, we'll concatenate that is, and then we'll concatenate on the degrees Fahrenheit. Oh, this is a value. So let's be a little bit more explicit. Celsius is, and then we'll have in the degrees Fahrenheit. And we can do that here. Perfect. So we'll have our degrees Celsius value that was input. We'll in our string here have Celsius is, and then the calculated value that we had calculated in the line before, and then Fahrenheit. And that'll kind of end the program. We won't have a sign off or anything like that. That should do it. Okay, fantastic. Now, one additional thing we should do before we're ready to go and implement this is to say, okay, we're going to code it, but how are we going to know that it's correct? We want to have some test values. So we can create a little test table here with expected values going in, what we would expect the values coming out to be. And this is a good time to do it. It's a good approach to take. Before we write even a single line of code, let's have some idea of what our program should be producing for us. So we can, there's any number of ways you can go about doing this, but a very simple way is to just create a table and put in some input values and some expected values. And then when we run our program, we'll record the actual values that came out. So I'm just going to, without inserting an actual, we'll do it. We'll insert a little table here in Word. Why not? So I want values for input. We're going to have the expected output and the actual output, and put in a couple of rows here. So, and I'll just say here, this is just a testing table. Again, more more formalized testing and how to do testing will be explained in future lessons. But for now, we're just going to keep it really simple. So this is our input value, which will be degrees Celsius. We're going to have an expected output, and that's going to be degrees Fahrenheit. Oops, kind of a stickler for keeping these things on one line. And then we'll have finally the actual output, and that'll be for degrees Fahrenheit as well. Now I'm going to go, whatever, it's fine. Maybe I'll leave it the way it was. Okay, so again, you might say, well, what values should we choose? We don't really have any fence post conditions, but to make it simple, I'm going to choose -1 degrees, 0 degrees, and positive. So we have both negative, 0, and positive values. If we get the correct output values for each of these inputs, then it's probably going to work for all values. And again, how to choose input testing variables is something we'll cover later. But for now, this is going to basically capture the 3 different cases we might come across. So you're going to say, okay, well, how do we figure this out? How do we know what the expected values are? And you could use your formula and run it through a calculator or on paper or however you want to do it. But of course, there are just online things that you could use. So I've already gone ahead and used Google to find the temperature conversion. So we can just come up with our expected and actual values from something like this. So I'm just going to say, well, -1, well, that should produce a value of 30.2. So we can enter that here. So -1, I would expect to get 30.2, something like that. 0 should give us 32, since that's just going to negate the multiplication here. So we can see that. And of course, +1 will give us 33.8. So now we've got some, based on these input values, some expected output values. And then when we run our program, we'll actually get to see what those output values are. Again, we won't look at formatting in this lecture. I'll save that for a supplemental video for you to see. But as long as the value is pretty close, which is to say it's essentially equal these numbers we have here, we'll be able to sign off on it and say, yeah, I think it's pretty good. Okay, at this point now, we are finally ready to get into Visual Studio and cut some code. So let's go over to VS and start a new project. So File, New Project. I'm going to create mine all kind of in the same place. Again, it's a console app. And I'm going to call this Lesson01 _ numbers and arithmetic. And my other options are all fine. I'm going to create it in the same place. And away we go. Okay, we get our scaffold and we're ready to go. Here now is the beauty of having a plan that's laid out in essentially a program statement for written statements sequence. I'm not left now in Visual Studio thinking what to do, right? Like I'm not going to scratch my head and what's the first step? We already know what the first steps are. We're going to declare some variables, right? And then I'm going to have to prompt for some input. And so that part of the thinking is already gone. All we're doing at this stage now is taking our plan and translating it for the programming language that we've decided to use. So again, no thinking there. If we're having any trouble, it's with the syntax of the language because that's new. But we're not confused as to what steps should take place in order to solve the problem. So I'm just going to clean this console write line statement up and I'm going to begin with our program. So first thing we're going to do is declare some variables. So again, we're not going to use the float type in C#. The plan here, all this does is indicate that degrees Celsius or degrees Fahrenheit should be floating point type variables. Implement them in whichever form, way, shape, whatever your programming language requires. The default in C# for floating point values is double, small d double. So that's what we're going to create. And again, even though here in my plan I've capitalized the first letter of my variable, in C#, the naming convention we're adopting is camel casing for variable names, so the first letter is going to be small d. Okay, don't be confused by that. Again, there may be some programming languages that have adopted a variable naming convention that is Pascal cased or something like we see in the pseudocode plan. But then there are others that are different. If this were Python, rather than having camel casing, we might have snake casing with underscores between words in the variable names. So be aware of what the standard is for the programming language you're using and adapt your plan for that programming language. So continuing on, this is degrees Celsius. That's fine. And we'll also create a variable for our degrees Fahrenheit. Perfect. Okay. So we've declared variable in the previous lecture was a string. Again, declaring variables, assigning values, and recalling variables and using them in output and expressions is always the same, right? It's the only difference that we have here between declaring a string variable and a floating point variable is instead of using string, we're using double. But it's still the type followed by the identifier or the name. And that's how we're going to declare all of our variables. The next thing we're asked to do is to prompt for input. And here's where things get a little bit different. So we can use, again, console.write, not write line. We're going to create the prompt, and it's going to stop on the same line, and then we're going to be able to enter our input on the same line right after. So the string here for output would be something like enter degrees Celsius. And here we're going to assign it a value. And if you recall from the previous lecture, we used console.readLine to do that. So we'll see that there's a problem with that, and then we'll talk about how to address it. So degrees Celsius is going to be assigned a value, which again comes from the console. And we're going to use readLine to read in a value from the user. But now we see we've got this problem. Okay, so the red squiggly line, if you remember, tells us, hey, there's something wrong with the code you've written. This isn't going to work. You're not going to be able to run this program. And so if you hover the cursor of the mouse over the red squiggly line, you get a little pop-up here. And it tells us it cannot implicitly convert type string to double. Okay, now just think about that message for a moment. It's telling us exactly what the problem is. Okay, so console.readLine, if we have a look at this method, it reads the next line of characters from the standard input stream. And more importantly is this type that appears right here in front of console.readLine. And here it says string. And string represents the return type. Okay, and what that means is if we call console.readLine, it will do exactly what it says here, but it's going to return that input value as a string. Well, what data type did we use to declare degrees Celsius? If we go up a few lines, you'll see that we declared degrees Celsius as a double. And so double and string, they don't match, right? So if you recall from the previous lecture, when we declare a variable, we indicate first the type of value that variable can hold. And in this case, we're saying degrees Celsius can only hold types that are double or compatible with double. And a string of characters is not compatible with that. So what we need to do is we need to basically tell the program, the computer, that I know this is going to read in a string, but I'm going to expect the user to have entered a number. And if they did that, I'd like you to explicitly convert it or parse that string into the type that I need, okay? And so that's the issue, right? It won't implicitly do that. The computer here is telling us, hey, you've got a double, this is a string. I know that, but I'm not going to just convert it for you. I'm not implicitly going to do that. But we can ask it to explicitly do it by using our parse methods on the int and the double types. So again, we know that it's a double. So here, let me just stretch this out. So here we can indicate double, dot, and you'll see we just like kind of console or the strings, double itself has some methods that we can call. So the one that we're interested in here is the parse method. And so if you wrap console.readline inside of parentheses for this dot parse call, you'll see that the red squiggly line goes away, everything looks great, and if you hover over the parse method here, you'll see what that does. Again, the return type for parse, double.parse, is double, so that's perfect. So this is going to take a string, it's going to try to convert the string representation of a number into the actual numeric value, and then it's going to return that as a double type so we can assign it to our double variable. Okay, so just take some time with that if you need to think about it a little bit more, but we can get all of that just from this statement. So console.readline, the user types in something on the keyboard, hits enter, we take that string value, double.parse will take the string, the character representation of what was entered, and try to convert it into the actual numeric value for a double type. And it will return that so we can assign it into this variable location here. Okay, another way to visualize that would be, for example, something like the following. If the user enters in the number 22.5, that gets captured as a string in quotes. What double.parse tries to do is take that as a string and convert it into its actual double numeric type. Okay, so with quotes, it's just characters, right? So the user could have typed in anything in here, right? Anything that's a string of characters. We're hoping that the student inputs just a numeric characters that could be converted into the numeric type. If they enter something that doesn't work, like let's say, for example, it wasn't clear what we had asked for, and it says, hey, enter the degrees Celsius, and they type in 20, that may be valid in their mind. They type in the word 20, it's 20 degrees Celsius, here's my input. But this isn't going to work for the program. So this would actually cause our program to crash the way we've written it. So again, we're putting a lot on the user, assuming they will give us values that we need for our program to work properly. And we'll talk about how to deal with exceptions in a later lecture. For now, we are just going to assume that we'll always get good values. When we learn how to deal with values like this, written 20 versus an actual 20, then we'll be able to correct our programs and re-prompt for input or send an error message to the console that says, sorry, enter it like this or what have you. But we don't know how to do that yet, so we're going to assume that we get good values and go from there. So that's essentially what the parse does. Okay, and there's an equivalent for integer types. We don't have any ints in the program at the moment, but it would be exactly the same as you would have read and gone through in the lesson for this week. So that's it. So that's how we can now input numeric types. We still utilize console.readline, but we have to use a parse method, either double parse if that's the type that we were interested in, or we would use an int parse if we were interested in whole numbers or integer values. So that's fantastic. The next step then is to do our calculation. So here we're going to assign degrees Fahrenheit a value. It happens to be, we'll use the parentheses, degrees Celsius. We're going to multiply that by 9 divided by 5, and then we're going to add our value of 32. So now we've created our first arithmetic expression. Again, here you'll see the plus operator. We've used that in the past, and we've used it to concatenate strings together. You'll see here it's the exact same operator. Looking at it, there's nothing that tells us it's any different from what we had done previously. But the fact that the operand on the left-hand side and the operand on the right-hand side are both numbers, that means that this will do an addition. Okay, that's just how it's going to be interpreted in the program. If either side had a string value, then the plus operator would perform concatenation. So that's the rule to keep in mind. And don't worry if you get confused or you try to do some concatenation with addition and it doesn't come out right. You can always ask me, send me an email or something, and we can figure it out. But If that's happening, just keep that in mind. That's probably the issue, and you will want to use parentheses to indicate addition versus concatenation within the expression. But this is, as we've written here, okay. One thing to note, the numbers here that we've used, the literal values, are in fact ints. And you'll see that when you hover over them, it tells us here that it's an int 32, right? So this is an integer value. And so some of you might be saying, well, if what we want is a double, shouldn't we implement these literal values as doubles as well? And it turns out that because whole numbers can be represented by double values, right? The range of floating point values includes whole numbers, that's totally fine. We can have an expression that contains integer values and assign the result to a double type variable. You wouldn't be able to do it the other way around, okay? So we wouldn't be able to assign a double value to an int type variable because the double would represent decimal precision. Even if the decimal precision was 0.0, we wouldn't be able to store the 0.0 in an int value or an int variable. So that would give you an exception as well. You would get an error here and it would tell you you're trying to put a larger type into a smaller type. And we probably explore that in a future lesson as well. But for now, that's fine. If you wanted to be explicit about it, we could just simply put .0 on the end of these literal values. And so now when I hover over them, you'll see that they are now doubles versus ints. But like I said, because int values can be used in expressions and assigned to double variables, leaving them as integer values is fine. Okay, so that's the calculation. The last piece then is to use our console.writeLine so we can display our output. And again here, I'll just display it using the concatenation that we had displayed here. So degrees Celsius, we'll concatenate that with is, and then we have degrees. Oops, I'm forgetting again my Celsius. I'll just use C for short just to keep it readable. And I don't want a space here on the end of the numbers. We'll do it that way. All right, so I'm going to Control S, save that. My output, I'm hoping, will give me the input number, degrees Celsius, concatenated with C, is, and then the calculated value in F. And we should see that. So now, rather than just run the program and input values and see if it works, we can actually input our values from our test case and see if the actual output matches now our expected output. So let's run this. Give it a second here to do its thing. Okay, so we enter in a value of -1. And it tells me here that -1C is 30.2F. And if we go over and look at our expected output, right on, that's awesome. So our actual output does in fact match our expected output. And that's now a successful test case. Okay, so this is a much better way of testing your program than just running it and entering values. If we had just entered -1 and we got a value back of, let's say, 30.1, without having any expected values to test that against, we might just clap our hands and say, you know what, it looks like it works. But then it doesn't work. We've actually got an incorrect value. So in cases like this, it's often very, very good to have a simple test plan, if not a formalized one. So again, you're not just entering random values and getting numbers to appear. You have a systematic plan in place. So we'll go through with the remaining two values just to complete our testing table, even though I feel pretty confident everything is okay. So we'll run it again. And this time we'll enter in 0. And in fact, we do get 32. So that's fantastic. We expected 32. We got an actual 32. And then the final execution here, we're going to use a +1. And we get a 33.8. And yes, the expected was 33.8. We're all good here. So as far as our testing goes, we knocked it out. It looks like our plan was good. We implemented it successfully. We had some testing that we could use after the fact. And when we did go through our little test table, things turned out the way we expected, which is fantastic. So that's that. That's our brief little introduction to working with numeric types and arithmetic. We didn't explicitly declare integer variables, but in a supplemental video, I'll quickly walk through the differences between doubles and ints, and also operators, arithmetic operators, and precedents, and show you a quick rundown of how those are applied in C# as well. But for the lesson, this hopefully gives you what you need to get going. I would recommend that you begin to look at the arithmetic exercises and try to run through a couple of those, if not all of them, to give yourself some practice. Yeah, so that's that. The final lesson video for this week will be a part of the lessons 2 for next week, which ties in strings and decision making. So look for that. That should be available shortly, and I'll look forward to seeing you then. Bye-bye.